Most WAN links in CCNA are either Ethernet or serial links, which makes discussions of IP routing pretty simple. Let's get into the basics together. First, let me give you the video context. This video mirrors content found in the CCNA Cert Guides from Cisco Press, Volume 1, Chapter 3 in this case. In particular, the first section of 3 from that chapters. There you see the section titles from that chapter. As always, I try to give you a different treatment here in the video versus in the books with different examples and explanations and perspectives. So in this video, I'll do 3 parts inside the video. We'll start by comparing what it means to be a local area network versus a wide area network. And then I'll talk about Ethernet as a WAN instead of a LAN technology. And then we'll talk about serial WAN links. This video is about the 2 most common WAN links for CCNA, but there are a few other WAN technologies. So if you stick around to the end, I'll mention the other few CCNA level WAN technologies just so you can keep an eye out for those as you learn about CCNA. As always, at the end of the video, I'll make 2 main promises to you. I'll talk about the book section again for those of you that own the books, so you'll have some advice about what you can skip and what you want to look at in that book section. And finally, for everybody, I'll point you to a review exercise so you can review the content in this video. All right, let's get into it. There are 2 major differences between LANs and WANs. First off, LANs are owned and WANs are leased. So here's what I mean by that. If you lease space in a building or you own the building, you can own the gear you put in there. You can own the LAN switches, you can own the cabling, you own the devices that create the LAN. However, with a WAN, the cables have to go in places you don't have the right to go into. The cables go out of your building and underground and under someone else's land. Often that land has right-of-way that's controlled by the local governments. The land is owned by other individuals and companies. You just can't go there, right? You're not allowed to put your stuff under their land. So one big difference is that you can own the gear because you control the space in a LAN, but you can't own the cables that create a WAN because you don't have the right to go there. The other is that LANs are generally much shorter in length, at least the links are shorter, whereas WAN links can be longer. WAN links could be tens or hundreds, literally even thousands of miles long in some cases, like something that crosses an ocean, whereas LANs tend to be in hundreds of meters, maybe in a few kilometers long. Now you'll see diagrams that look like this with routers and hosts connected to LANs and WANs with more details than you see here. But in general, LANs owned and short, WANs are leased and long. Now for CCNA, the focus will be more on routing over those LANs and WANs than about the WANs themselves in particular. So like that PC1, when it's routing and it's sending packets, it's using IP logic, it wants to send the packet to some nearby router, like router R1. So it sends the packet to router R1 over a LAN. And R1 gets the packet and sends the packet to router R2 over a WAN. And then the packet gets to router R2, and R2 sends the packet to server S1 over a LAN. But the routing logic is the same, whether it's a LAN or a WAN that we're using to transfer the packet. All right? Now, there's more detail than that, and you'll learn more and more about routing as you go through your CCNA study. Just to take a closer look right now, to move an IP packet across a LAN, you can't just send the IP packet without other headers. That IP packet, as defined at layer 3, needs to sit inside, needs to be encapsulated in a layer 2 frame. So there'll be a layer 2 protocol, a LAN protocol, whose frame encapsulates the packet, as you see there. That's probably Ethernet, all right? And the frame makes it to router R1, and R1 removes the packet and then puts it in another frame. It's kind of like you make a trip in a small truck and then you make a trip in an airplane. You get out of the small truck and then get in an airplane, so you make it to the destination. But the truck doesn't maybe, say, go on vacation with you down to the islands, so to speak. So that original packet gets put in a WAN data link frame. The frame gets over to router R2, who extracts the packet and puts it in yet another third frame here, this one using a LAN header and trailer. Now let's take a closer look at Ethernet in particular. If you see a diagram like this with two routers and a line between them, you don't really know what type of interfaces the routers use or what type of link it is. However, you might see an Ethernet WAN link drawn like this. Conceptually, it means you've got an Ethernet link with Ethernet interfaces on the routers, and they can both send in each direction. In lab, you could make this just with a crossover cable between the two routers. In most drawings, and in particular in drawings in my courses and in my books, I'll use the idea of a little cloud, not a large cloud, but a little cloud in the center as a reminder that it's a WAN link versus a LAN link. So that would represent an Ethernet WAN link. Now, there's a lot more to it behind the scenes than what you see in this diagram. For instance, if you think of just an Ethernet link between two routers that sit, say, 20 kilometers apart, or maybe 100 kilometers apart, there has to be more there. For instance, the routers don't connect with a 20 or 100 kilometer Ethernet cable. That'd be ridiculous, right? In fact, there really aren't any standards that go much beyond 100 kilometers, and that is really an extreme case for a single link between two devices. So what really happens? The router connects to a switch owned by a service provider. Router R2 connects to a switch. Router R1 connects to a different switch. And we call those access links. Then the service provider builds something in between those switches that they use to let you access the network. Those links still need to be fairly long compared to a LAN, so they often use fiber links, maybe 2, 3, 4, 5 kilometers long between the router at your site and the switch at a service provider's site. Then taking a little closer look, the SP doesn't really need to tell you about what's there in the middle of their network, but they'd have other links to other devices that understand Ethernet and LAN switching. For instance, you might have a 1 gigabit link between your routers and that switch owned by the service providers. They'll have a bunch of other switches in between with much faster interfaces to build capacity to support you and other customers like you. But the bottom part of this slide shows the concept of what you receive from them, the service that they provide, which is basically the equivalent of a 1 gigabit per second Ethernet link between those two routers. To pull it back into the focus of CCNA, which is routing, if we've got that Ethernet WAN link in the middle, routing still works the same. The PC sends a packet to its nearby router. The packet's encapsulated in a LAN frame using Ethernet as the data link layer. Router R1 removes the packet from that frame and puts it in a different Ethernet frame, one that's appropriate for that WAN Ethernet link. That WAN Ethernet link flows over to router R2. R2 de-encapsulates the IP packet, that is, removes it, puts it in yet another Ethernet frame, one that's correct for the LAN on the right, and sends it on its merry way. Now let's talk about serial WAN links for a moment. Looking back over history, starting back in 1960 all the way up through this decade, serial links were the predominant WAN technology coming into the 1960s, up through the 70s and 80s, and into the 1990s. Now, there were others in there, but the ones that pretty much usurped it were frame relay and then MPLS in the timing that you see there. Now, you'll still see some MPLS today. Frame relay's pretty much gone away. But MPLS has begun to wane, and Ethernet as a WAN technology has come to surpass it. So what's going on there? Well, Ethernet obviously grew up as a LAN technology, but the IEEE built more and more different kinds of physical links, some that support longer and longer distances, so it became useful as a WAN technology to the point where more and more WAN links are just Ethernet links, with lots more detail behind how that works. So you might represent a serial link with a straight line between two routers, but not very often. But a serial link lets the two routers send data in both directions, but will often represent it with this jagged line like a lightning bolt. So that's the common way we represent a serial link, generically speaking. But of course, there's much more behind things than just the lines in a diagram. First off, there'll be something called a WAN switch in the service provider's network. There'll be a short link, short as in, a single-digit number of kilometers between each router and a WAN switch owned by a service provider, as you see here. For instance, if the two routers are 200 miles apart, they don't create a cable that's 200 miles long and pull it under all those streets. It'd just be way too heavy to do that. So it's a series of shorter links that are configured and programmed to connect together in these WAN switches that are represented there generically with these little gray boxes. So that's part of the serial link. The service provider doesn't have to tell you the details of their network, but it's a similar idea to what we saw with the Ethernet diagram just a few minutes ago. Now, one popular speed for a point-to-point serial link between two routers happens to be 1.544 megabits per second. That's megabits, not gigabits. So remember the era in which they grew up? There were certain years in there in the 70s and 80s for which 1.5 megabits was really a lot of bandwidth. So not very fast by today's standards, of course. The service provider then would add lots more WAN switches with faster links than that to create capacity to support lots of customers and their 1.5 megabit per second links. What the customer gets, what you and I get as the owners of those routers, is this idea of a cable between our two routers, a serial link where we can have each router transmit in each direction, transmit or receive to the tune of about 1.5 megabits per second in this particular case. Serial links supported all sorts of different speeds, but that was a very common speed to use. Overlaid on that, of course, we've got routing. The routing logic is just as it was in the Ethernet WAN case. The PC encapsulates a packet in an Ethernet frame for the LAN. The router de-encapsulates, but it puts the packet in a data link layer frame appropriate for serial. Serial links don't use Ethernet as the data link layer protocol. Notice PPP, that is the name of a data link protocol that you can use on serial links. Another is HDLC. So that's the data link protocol in that case. The frame gets over to router R2, who de-encapsulates the packet and re-encapsulates it here in an Ethernet frame to send it the rest of the way over to server S1. So for those of you with the book, what do you do once you finish this video? Well, open up Volume 1, look at Chapter 3 in that first section. There are a couple of things you might want to look at there. First off, there's a table that shows synonyms for the term serial link, so check that out. There's also a figure that shows the HDLC frame format. That can be useful as well. Also, if you have the book, there's an additional review exercise you can do. There are part review questions included with the book, and Chapter 3 happens to be the last chapter in Part 1 of Volume 1. So what I would suggest doing then is do the part review questions, say once you've finished all of Chapter 3. So use the app, the PTP app that includes those questions. Look for the part review questions and select only the Part 1 questions there. Now, anytime you're using questions for review and exercise, you can do them anytime, and that's better than not doing them. So that's a good thing. But as always, spacing out your practice is more useful than doing it immediately. So that's better. Also, anytime you're doing questions, don't guess. Let yourself miss questions if you really don't know what all the answers mean, and that uncovers gaps, and those gaps tell you what you need to go learn more about before exam day. And finally, if you want to be amazing, schedule your review activity for a few days from now to make sure you don't forget it. Now, those things are for people who own the book. You don't have to own the book. I'd love for you to, but you don't have to, so just go to the blog. I've got plenty of blog posts that have sample questions there. I will warn you that I've written those over about 15 years, so the format varies wildly, but there they are. You can look there. They're sorted by book organization as well, just to make it convenient for anyone that's using the books. Also, follow the same good practices I just described about making the best use of your time doing practice questions. Well, other than Ethernet and serial WAN links, what else does CCNA say about WANs? Well, almost nothing, to be honest. There's a real basic exam topic that mentions the word WAN, and then there's one exam topic that mentions VPNs, specifically IPsec remote access VPNs. That's from your computer, say, to a website. And then there's site-to-site VPNs that you'd set up between two sites to send traffic over the internet, but protect it and keep it secure using VPN technologies. So keep an eye out for those as you go along, but most of your exposure to WAN topics in CCNA will be these Ethernet and serial links that we just talked about. Thanks for staying till the end, folks. If you're new to the channel, please subscribe and click a bell to be notified when I come out with some new videos. For those of you used to the channel here, as always, leave me a comment. Let me know what's on your mind. Like the video if you do. And, of course, share with others. Help me build up the channel and encourage me to make some more of these things. Hey, thanks for hanging out. Talk to you soon.